Good afternoon, New York. I'm Sunil Malia. I'm part of the Machine Learning Solutions team at AWS. Today, we're actually going to talk about how we can use SageMaker to simplify machine learning. Just to get a quick sense of who's in the room, how many of you would consider yourself first time or new to machine learning? That's an overwhelming majority. And my hope is by the end, you actually get a good sense of how you can simplify, apply machine learning to your business problems. Machine learning has been helpful in solving some of the hardest problems in computer science, ranging from, be it face detection to analysis, to medical imaging, with cancer, etc. So we've been applying this at Amazon for more than 20 years now. And you've seen this with our personalized recommendation. When you go to the Amazon.com website, you see the personalized recommendations on products. In our inventory and fulfillment centers, we have robots who actually lift and bring the ordered items to actual workers, be it drones, and also, something that's really common these days with the Alexa device, the Echo device, you see us interacting with a computer in a human language interface. And you also saw you might have seen this at Amazon Go Store, where you can literally walk into a store and pick up things. Almost feels like shoplifting, but you get charged. We have tens of thousands of customers running machine learning workloads on AWS today. And it varies from almost every industry vertical is represented here. And you can look at, in the financial sector, Intuit, Moody's, using Amazon, AWS to actually build machine learning solutions. You see FINRA as well. And then if you go to other sectors, you have GE Healthcare and Cerner actually using machine learning in healthcare. And we have a lot of startups, including Clarify AI, et cetera, ZocDoc, using machine learning on AWS. What's our mission? We literally want to put machine learning in the hands of every developer. We want to simplify the machine learning process, and we want you to concentrate on applying machine learning and unlocking business potential. Let's take a look at how we categorize different services and how we look at machine learning at AWS. So at the top level, you have application services. Here, we actually provide, whether it's computer vision or natural language services, as an API, which means you as a developer with few lines of code can actually have access to pre-trained models that our research teams have worked hard on building. And as far as you're concerned, you can just call an API and do facial analysis, or get understanding of natural language processing for sentences or documents, etc. Also, you can build chatbots using Amazon Lex. Now, a layer, or the bottommost layer, is where we say the bleeding edge. This is where a lot of the research, where if you're building a lot of cutting-edge technology, we have provided and made it easy for you to access the latest and greatest of deep learning and machine learning frameworks, like Apache MXNet, PyTorch, TensorFlow, all that is accessible. And we'll sort of concentrate more on the platform side, which is Amazon SageMaker today. Now, if you're a data scientist, or you happen to be an advanced researcher or practitioner, we provide the most popular of the deep learning frameworks. Now, from an infrastructure point of view, we provide access to the latest in technology here with respect to GPU. We provide the Volta hundreds GPUs, which have petaflops of compute, over 5,000 tensor cores, and proprietary NVLink to link between the GPU interconnect. But also, we have the latest in the CPU world as well from Intel. So we have Skylake GPUs in our C5 family, where our instances have 72 vCPUs, 144 gigs of memory, but also improved instruction set, the AIX 512, and the Nitro hypervisor as well. Let's get an idea of what a typical machine learning workflow looks like. You always start with the business problem. So clearly define, this is the problem we're trying to solve. And the next step is, you have business objectives, but this needs to be formalized as a machine learning problem, whether you're trying to classify something or you're trying to predict something or forecast. So we need to model the problem with the right objective functions. In the next process, we go after data collection. We try and identify or clean the data, right? Like the data in practice is probably not in the format directly that we want to consume. And the next point is we want to understand what are the features that are in the data that are going to help us solve the problem at hand. And so the next step is we pick a model or an algorithm that we think is going to solve, and then we're going to build it. We're going to tune the model. We're going to evaluate. At this point, we sort of want to check, hey, has this model or algorithm solved the problem that we are trying to tackle? If no, you go back, right? Like we go back, hey, is that more data that I can collect? Can I extract new features that are actually going to help me solve the problem? So it's a very iterative process. And sometimes it also involves augmentation of features. It can be, for example, let's say time series as an example. You might want to, if you have discrete or continuous time, maybe aggregating or adding another feature saying, hey, is this weekend or not? Or is this day or night? May help your model to better solve the problem. So things like these you do at this step. And then once you have met the business objectives, what you'll do next is go build or deploy the model in production. And then we do the predictions. But really important at this step is you want to know how, A, your model infrastructure is performing, but also you want to really be sure that whatever predictions are happening, what is the performance, accuracy? Because oftentimes what you have in the wild may not translate what you've built. So you want to be constantly monitoring and checking how does it looking in production. And then at this point, with that information that you have, you feed that back. Hey, do I need more data? Can I rebuild the model, collect more data? So it's a continuous cycle of building models, identifying the performance, tuning it, and then redeploying it. So let's identify who are the actors for each of these steps. So you have the analysts who help you frame the problem. And this is where domain knowledge is really important, right? Like if you're a finance or healthcare, there might be specific things that help you formulate the problem. And data collection and ingestion, we have services that help you clean the data, format the data. All of that ecosystem exists today. With Amazon S3 as your data storage to help you store But once you have that, you have serverless AWS Glue service to do ETL. You've got Athena. Again, you can query at scale with the data that's in S3. But you can also use Elastic MapReduce, Amazon EMR, a Spark to transform the data, create features, have that. So next, let's look at what we're trying to do here is we're trying to do the underlying undifferentiated heavy lifting so that it's simpler for our customers to build solutions on top of our services. So with SageMaker, we'll dive more deeper in the coming slides. But there's a hosted notebook environment where you can explore the data, understand what features. All of the data analysis, visualization, and training is combined here with Amazon SageMaker. So let's come to where, as a user or a developer or data scientist, where should you be spending time now that we have defined and agree on a machine learning process? So I'd like you to remember 3 things by the end of the talk. First, build. So with build, we provide a notebook interface where you can go build up, where you can collaborate and build your notebooks. Second, train. Once you've identified the problem, formulated, you code, and you say, hey, SageMaker, train the model. Once you've trained that, then you can go deploy the model onto your infrastructure. And we simplify this for you. So typically, as we talked, with training, you have the GPU and CPU option. Again, with deploy as well, you've got both the options. Also, on the model deployment side, what we've seen a lot of customers tell us is using the C5 family to host the models, which have the Intel Skylake GPUs. We've seen customers get better price for performance with that. To summarize with the build step, we have pre-built notebooks, high performance algorithms, all that provided you as far as the building aspect. With training, we've simplified training. It's one-click training. You can also tune and auto-tune your models as well. And then deploy, one-click deploy. You have a scalable endpoint where you don't need to manage your scaling infrastructure. So in all, build, train, and deploy, all of this is actually managed by Amazon SageMaker. And to top that, compliance and audit capabilities. So Amazon SageMaker is a HIPAA-eligible service. It's a pay-as-you-go service, which means that if you happen to train, your model training happens to take 519 seconds, you're only going to be charged for 519 seconds. End-to-end encryption with KMS. The data stored in S3, when you bring it into your training infrastructure, it's end-to-end encrypted. All of this can be in your VPC, is execution. So security has been, I want to say, priority 0 as far as the product has been concerned. So we've been very mindful of treating that and bringing that as a first-class citizen. So really, really important, as you've seen, with customers in healthcare and finance and other sensitive sectors using this product. Let's actually look at how SageMaker training looks like. Let's go take a console view. So Unfortunately, I don't have a dual screen here, but we'll follow here. So we actually support multiple frameworks, as we saw. PyTorch was one of the latest ones we added. So I'll show you a quick idea of how that training in SageMaker looks like. But before that, this is the SageMaker Console, where you have a view of what notebooks, instances that you want to have. You can look at configurations, training jobs, etc. So a notebook instance is a place where you get a hosted Jupyter environment where you can collaborate with your colleagues. Your building and sort of sanity checks all can be done in this infrastructure. If you're familiar with launching an instance in EC2, it's even more simplified here, where you enter a notebook name. You've got different instance type, all the way from T2 instances to medium to instances with GPU attached. So once you hit Create Notebook, you can get a list of notebook instances. And what's great is you can just hit Open, and you get a nice landing page of your Jupyter console, where you'll see it already comes pre-populated with a lot of example notebooks. So you get this nice browsing interface where you have examples varying from simple ones, even if you're new to machine learning, on doing, say, churn prediction, or if you just want to look at, hey, how can I bring in a Docker container and train my own algorithm, to using some of the available ones with TensorFlow, Apache MXNet, or PyTorch. So I've already clicked one here. So we'll take a look at how to train a model with PyTorch. Now, the problem is we're building a language generation model. So we'll concentrate less on what the model actually does, but more on the process of how easy it is to actually build these models. So what we do is initialize a SageMaker session. You see that. And then this is the part where we get the data. So in this case, we're using a Creative Commons data set, which basically has a lot of documents. But once you've done that and transformed the data, the next step is we'll upload the data to S3. And that will be where our data gets ingested into our training infrastructure. And what you can have is you package your code into a training script, which basically has a hook to call a train function. So you can have a train, you can have a load. We provide you 4 functions that you can override as entry points for various steps. Then this is where we'll concentrate most of the time. What you do is you provide your training script. So you've come up with a model that you want to train, and you give, hey, I want to use the PyTorch, because we're launching a PyTorch job, and then we're going to give it a train.py. That is our file with all the code. The second line is we specify which IAM role, which defines what access it has. Framework version, again, different. We provide multiple versions for different frameworks. You specify the instance count. You specify the type of instance you want to train. And then hyperparameters. In this case, we're saying, hey, run for 6 epochs. Now, what's great here is I can just hit the fit function. The training cluster gets spun up. We train the model, and the model gets saved in S3. And we can actually stream in the logs here. It has integration into CloudWatch. So CloudWatch logs whatever logging you put in your scripts. You can see it there. But also CloudWatch metrics as to how much is your instance utilized. And what's great is, imagine like our data corpus here was around 1 gigabyte. Let's say I had 100 gigabytes of data. Now, it's ideal that, hey, I'm doing this in AWS. I love the scalability and the distributed aspects of that. How do I do that with SageMaker? All I need to do is, with a single line code change, now I can run this distributed. So I just had more data. What I do is change the instance count, and SageMaker handles the distributed scaling aspect for you. So you don't need to write any extra code for you to do this. And this is true for the other frameworks as well, with TensorFlow and Apache MXNet on SageMaker. In addition, we do provide algorithms, built-in algorithms. I'll summarize some of them later. And what you need to do is, just like we selected a framework, we need to select a different image to say, hey, I want to build a forecasting model with a built-in algorithm, or I want to use XGBoost that SageMaker provides. Let's go back to the presentation. So to summarize, these are the capabilities. You can have your data, format that for the machine learning process. And then you have the option of selecting one of the dozens of algorithms we have that are built in. The second is, we have a lot of notebook templates. Like the template that we saw earlier, we have a lot of code and documentation. What you can do is take that code, which is open source, modify that, use the process, and apply it to your data. So we're encouraging you to use that as a template for you to build on top of. And then for custom, you can write your code in Apache MXNet, Gluon, TensorFlow, PyTorch, Chainer, and then launch just like the job we saw earlier. But also, there are cases where customers have told, hey, I have my own algorithm. I want to use a version that you don't support yet. For all those cases, all you can do is build your Docker container. We have templates. You can take that template, modify that, build your own custom Docker, and then spin up your training. And training is supported either be it single machine or cluster. And as you saw, doing distributed training is as simple as changing one line of code. Let's look at what we want you to focus on, which is we've removed or we've done the undifferentiated heavy lifting so that you can increase the training speed by, we've done optimizations as far as getting data in, be it at the hardware hypervisor level, be it with the framework level where we provide and make it easy for you to distribute training. On the inference side, where we've deployed the model, it's auto scales. You can set the parameters as to min and max instances. But more importantly, what we have tried to do is provide a platform where you can iterate faster. And we understand the business needs are not static. We want it to be dynamic, make it easier for you to iterate and build algorithms. So I want to actually talk a little bit about some of the new features which we launched in a little detail. So as you saw, hey, I spun up my notebook instance. I have to now submit my job and spin up a cluster. What a lot of customers found that was, hey, I need to wait for my training cluster to spin up. So, hey, I had a mistake. I had to go back and correct it and launch again. But turns out I have another mistake. So we wanted people to iterate fast. So what we did is we introduced local mode. What that allows you to do is run the code that you have, maybe for a couple of epochs or a single epoch, where you can go test your code. Because sometimes these jobs can run for hours or days. You want to make sure that there are no issues as far as your code. You need to do a sanity check, be it on the algorithm side or the code side. So now, what we allow you to do is train. You can do complete training on the notebook instance that you have, or you can do sanity checks and then submit the jobs. The next thing is automatic model tuning. When you've sort of found the model architecture that helps you solve the problem, let's say you're at 90% accuracy, but what you really want is try and get to that 95%. And oftentimes, what you find is it's those parameters that build up your model need to be tweaked. Now, there are various ways to do this, and traditionally people have used things like random search or grid search, but grid search or other, how do you start? Where's my base? And things can have with grid search, you can have combinatorial explosion as the number of parameters increase. So we've made this easier for our customers by allowing you to do automatic model training. Here's an example for hyperparameters with XGBoost, where we have gamma, what's the tree depth, etc. So this is how the process for doing hyperparameter optimization or model tuning look like. So we have the client, the console we saw. We specify and configure a job. And the next thing is we pick the tuning algorithm, or rather the tuning algorithm picks and understands the hyperparameters, picks one. We actually use Bayesian optimization here to pick the best algorithm or the hyperparameters, and then we kick off the training job. Now, what the training job is looking, or rather the whole process is looking at the objective metrics that you've defined. This can be something that you've custom built, or you're saying, hey, look at the validation accuracy, or look at the area under the curve, whatever is the important metric that you want to tune on. And then we collect the objective metrics, and then we feed that back to the tuning algorithm and understand, hey, I moved these things, this is the result. How can I pick the next best hyperparameter so that I can get the best of the metric that we picked? And this is done iteratively, and the training happens. And what's great is all of this is happening in parallel, right? Like, you can say, hey, I want to tune my model, but don't do it serially. Spin up 4 jobs or spin up 10 jobs in parallel and find me the best model. And all this is completely managed for you. All you need to do is write those lines of code that define your objective metric and parameters, and then do it exactly how you did with your training previously. And we'll look at the code next. And then you get this nice tabular data which says, hey, what was my objective metric? What are the other parameters, hyperparameters that were used? So this allows you to pick what we think is the best model that you want to go ahead and put it into production. And here's some code. So this is the job. We pick certain hyperparameter ranges, and with neural networks, it's typically, you'll see the batch size, learning rate, give me what are the number of epochs I want to run. So there's no manual. You don't need to manually run something for, say, 50 epochs and then try and run it for 100 or change different setting, right? Like, you have these many dials. The best way to think about this, there are many dials for a machine learning model, and which one to sort of pick and dial is made simple by the automatic model tuning feature. And then, in this case, we pick the objective metric, which is validation accuracy. And as you can see, it's got regex support. So if you're logging custom things, it's easy to extract and tune for. And then you wrap your estimator. We saw earlier in the hyperparameter tuner job. You specify the ranges, and then you hit the fit function just as we did before. And now jobs are running in parallel, being optimized in the process that I walked through earlier. And then this is an actual job that was run. It's plotting time versus accuracy. So as you can see, it doesn't mean if the model runs all the longer, you pick the best model. There's a sweet spot somewhere. And as you can see, our highest, we want to get the best accurate model, and we can see the hyperparameters there. Hey, it was batch 16. It ran for 39 epochs. So that's the model I want to pick and deploy to production. So let's look at some of the customer success stories. We've had a lot of enterprise customers like GE Healthcare, Dow Jones, build on top of SageMaker. But at the same time, we've had a lot of startups, including Tinder. You probably saw some, if you followed the keynote, you saw Matt talk about how Tinder was using SageMaker. But Grammarly, Intuit was a launch customer for SageMaker. So we saw what was great was Intuit told us that, hey, we wanted to accelerate our machine learning. And some of the core principles that I talked about is we wanted to decrease the time that it took to build the model. And we were able to reduce, and we've seen this with multiple customers, is reduce that time that took 6 months to go from an idea to production, and reduce that in a matter of weeks. Currently, we have Intuit churning up models and building new models in less than a week and productionizing them. So this is an architecture of a fraud detection, real-time fraud detection system that Intuit uses. They use Kafka to ingest data, and then to actually transform the features, they use Amazon EMR and Spark. So as you see, the reader, cleanser, and processing is happening. And they've built this feature store where all these features get mapped. Once you have all these features, what we do is they kick off a training job on SageMaker. And then the model gets built. It's stored in S3. And then, as you saw, like with a single line of code, you can specify the number of instances that you want the model to be hosted on. And then it gets hosted in this auto-scaling infrastructure. And then you can have your client services consume that as an API. So in the next 10 minutes or so, we're going to dive into key differentiators, like what separates SageMaker from, or what are the key features there. There's literally zero setup required for you to do data analysis and explore your data. And as you saw, all you need to go is in that console, specify a couple of things, and then you have your notebook instance ready to be accessed. Now, The notebook, depending upon the role you set, already has access to S3, so you can bring in your data, you can kick off your ETL jobs, and then, because this is a Jupyter Notebook interface, which is popular among a lot of data scientists and developers, you can explore the data, write plots, all of that. But also, as you saw, we have a lot of these notebook templates that make it simpler for you to get started with machine learning. So you can go from data and transform the data and then use one of these notebooks. So we've got algorithms like DeepAR, which is an algorithm that Amazon internally uses to forecast inventory. So that algorithm is available for you. So if you wanted to do forecasting, any time series forecasting, as long as you can format the data in what the algorithm requires, in this case, DeepAR takes a JSON format. Once you transform that data, you can kick off a job and get a model. You don't need scientists or data scientists on your team to go and build these algorithms. Such algorithms are available readily for you on Amazon SageMaker. The next, what we were really mindful is the scale. We operate at scale at AWS. So we want to be mindful and bring that capability to all the algorithms that we provide. So for example, we have anywhere between like matrix factorization, we have k-means clustering, gradient-boosted trees. All these algorithms are available. And what we've done is we've actually built these algorithms from the ground up, but keeping the functionality the same. And these algorithms are built so that it can work on streaming data. So we have constant memory footprint, and you can stream in any amount of data, and which allows us to scale and build these models. What that means is you can, if you have more data in a trained model, you can load that up and keep training that again and get a better model. We've typically seen is these algorithms have performed 10x better than the nearest implementation that's out there. And it's the same, like, we have capabilities with these built-in algorithms, the notebook algorithms that we saw. You can have build your own models, Dockerize, and bring them into SageMaker. Next is managed distributed training. So it's as easy as a single line code change to go from training on a single instance to a distributed cluster. But we understand that our customers have different needs. So there's flexibility there in terms of you could bring your own container as well and configure to do that. So in case of if you happen to use, say, Apache MXNet, TensorFlow, Chainer, or PyTorch, you can fetch your data, you can put it through the training code, and then your model artifacts get saved in S3. And on top of that, for any of these combinations, automatic model tuning or hyperparameter tuning is provided, so you can find the best model for you to take to production. And all this is happening in your VPC, and all that we talked about is being fully managed. So AWS, or in this case, Amazon SageMaker, is doing the undifferentiated heavy lifting on behalf of the next is deployment. I want to get a sense of how many people think that training models cost more than, say, hosting. How many of you believe training is more? There's a few, a lot of smart people here. Yeah, it turns out like a lot of time is actually spent or on the cost side is on the hosting side. So because this is when you've packaged the model and you're actually exposing this to derive business value, right? So we've made it simple for model hosting, and we understand that not just having a single model may be sufficient, but you need to try and find the right model. So apart from hosting, say, a single model, which is great, we also understand that you might want to have multiple versions of the model. Or you might want to test out a model and pick the best that works in practice. So you can have different model versions. You can set A/B testing, different weights for each of those models, so that you are actually getting metrics, objective metrics on what performs best for you, so that you can use that and on full traffic. So all of this is actually managed for you. So to summarize on the model deployment, it's one click, A/B testing is supported, low latency and all the parts are independent of each other, which means that, let's say you already happen to have a training infrastructure and trained your models. You can bring those models in and package them and host them on SageMaker. The same is true with training. You can train your models. It's still stored in S3. You can download the models. And if you want to push it down to the edge, or if you want to use that in a different environment, you're free to do so. Let's look at some. We've actually been keeping up and building a lot of new enhancements. So I just wanted to summarize those for you. Recently, we launched new deep learning framework support with Chainer and PyTorch, security and compliance features. So SageMaker was HIPAA eligible a month or so ago. We've expanded worldwide, so Tokyo, Frankfurt, Sydney, it's available in those regions. Automatic model tuning that we saw was released recently. The local mode, where you can train locally or train partially locally and then spin on a different cluster, that's in. We've been constantly iterating on the algorithms. For example, with deep AR, we actually, to do time series forecasting, now it can, for example, handle missing values. We added more enhancements to blazing text to build your own word-to-vec-like models. And today, we actually announced TensorFlow pipe mode. So if you're using TensorFlow, what that means is you don't need to download all of the data onto your training instance before you kick off the job. Well, you can now stream your data directly from S3, which means that your training jobs start faster, which means they end faster, which means you pay less. So it's a win-win situation with the pipe mode. We've done a lot of benchmarks, and one of the benchmarks shared is on like a 78 gig data set, we saw the startup times increased by about 87%. And the overall training job was 35% faster than while you had to wait for all the job. Batch transform is an important feature. A lot of customers asked, hey, rather than calling a single endpoint, how can I give a bunch of images or text and get inference? But not only that, if you have large files like HD video, or in the case of medical image analysis, the MRI images tend to be really huge. How do you get that and process in a batch? Also wanted to present end-to-end architecture, a sample architecture, in this case to do style transfer. So we build using the notebook instance. And what we've also added now capability is you can isolate the notebook instance which means that there's no internet connectivity, right? When you're working with sensitive data, it's really important that you isolate the access. The next is it also has lifecycle hooks, which means you can integrate to code commit, which is really nice because now, let's say you stop, somebody can check in the code, and you can stop your notebook instance, but the next time you check, actually spin up, if somebody has had a new commit, you can actually have the latest commit and code for you to work on. So all that is integrated. And then in this example, we pick up the training algorithm. You kick off the SageMaker training job. And then it trains. The model artifacts get saved in S3. And then you can use API Gateway and Lambda to utilize or actually hook into SageMaker hosting to provide an external endpoint for customers, your end customers, to consume. And of course, you can use S3 and CloudFront to accelerate the access to static assets. Again, to highlight, you can have end-to-end VPC support here, but also, let's say on the training data, you have end-to-end encryption so that none of your data is securely transferred from S3 to your instances. So train and then deploy. So to summarize, what's important is we have the broadest and easiest to use machine learning platform with the most customers. So for your data lake storage needs, you have S3. Then compute, you can use the GPU instances with our P2, P3 family, but also if you want to, and that's when you'll have to manage, but as you've seen, SageMaker can simplify that immensely where your build, train, and deploy aspects are managed for you by Amazon SageMaker. It's got enhanced security capabilities and compliance, and also we have a lot of customers in different segments, be finance or healthcare, or even a lot of startups using Amazon SageMaker to solve business problems. So thank you so much. So I hope you'll submit feedback. I also want to leave you with useful resources that you can get to learn a lot of different things I talked about. A lot of GitHub. There's a lot of open source code out there. Please feel free to reach out if you have questions. And I'll be here after the session to answer questions off stage. Thank you so much.